So let's just continue from here. So just now I have did on the redistribution has been done, and now you can see that on router number 1, go to 2001 column 5 are using this as a next hop. And now I just quickly just enable for all the devices running as a IPv4. Okay, running IPv4. So on router number 1, when I enable IPv4, I just have to do it on the interface. Okay, so this is just a step that what we go through yesterday. Just a quick one. Interface gate 00 ISIS enable 1 interface gate 001 ISIS enable 1. Yeah, just to enable on the interface for all the devices from R1, R2, R3, R4, and R5. Just enabling. That is just IPv4. It's just a basic enabling. Okay, now just enable using this method. And when I go to router number 1, hold on, because just earlier on I already do the import out on router 4. Okay. So by right, in this case, I should have this 000 1011 10.1.13.3. Okay, because right now you can see that the calculation from this shutter path 3 for router 1, they do it separately on the IPv4 routing tables and also IPv6 routing tables. For this, you need to enabling the multi topology. Without the multi topology, so this will be not work because of I can't forwarding this information out by using the bottom path, because I have only import route on the IPv6 but not IPv4. So that is why we call this as a multi-topology. When using different V4 and V6, they can build their own topology. You do not need to share a single topology. So when right now I check on this, I displayed ISIS, LSDB, level 1. Then I put the 000 002 300-00 robust. So you can see that from here right now, when I receive the information, they will show me that this IPv6 is under the multi-topology number 2. Okay, empty topology number 2. They are not combined as one, they are split to 2. So that is my IP internals. That is my IPv6 reachabilities to tell that right now I'm running on the multi topology. Okay, So on the interface address and interface address v6. So you can see that they are also shared inside the same LSP. But when they gather this information, they do their own calculation under that topology. They are not calculated as one, they calculate as a separate entity. So and this over here, you can see that the topology, they do to have a IPv6. Just now it's just a standard. Right now they have a IPv6 as well. Standard and the IPv6. They call as a multi-topology. So this is how we enabling on the multi-topology to specify that every single device based on the different protocol to define the own shortest path tree. Is that okay? That is just what I want to highlight to you, that how it shows when they have a multi-topology is how you work. Okay. So display IP routing tables and display IPv6 routing tables. So they will have a slightly difference compared these two, because they're going to have two different shortest path tree. Shortest path tree of IPv4 and the shortest path tree of the IPv6. But for the IPv6 is a bit difficult for you to really go through one by one, because v4 it'd be easier because it's only 32-bit. But this one, they have a long information, 128-bit. That's why they need to show in a different line. Okay. But over here, they show you that in total, you have 17 route in total. So at least that when using the IPv6, when I displayed IP routing 5555, display IPv6 routing 2001:5::. So one is using default route and the other one are using the detail route. Is okay? This one is just what I want to highlight on the multi-topology. So always check when you have multi-topology, this is what you get. Okay. Inside the single LSP, that's what you have. You have two information, but they split these two to do the different calculation, a different calculation. So at least that you can see the reachabilities are different. Okay. And you can display ISIS, LSDB. LSDB are the same, it's still the same compared to v4 and v6. They do not have incremental of the LSP information. Okay, they only combine all the v6 and v4 inside a LSP. It's not like the OSPF. OSPF, you need to have a dedicated LSA to carry the information. But this one is just using back the level 1 LSP and the level 2 LSP. So far, all right? And one more things I want to show over here is on the authentication. Authentication, you can do it on the interface or using on the area or the domain. Okay, ISIS, area authentication mode, or either is area or is routing domain. Okay, it's a domain authentication. So it can be area authentications or the area or the domain authentications. Yeah, these are the two options they can define. From behind, it can be defined as an MD5 or symbol password. Okay, so make sure that whichever running level 1 is area, whichever running level 2 is a domain. And let's say you want to just go for interface, it's just for the hello, it's just interface authentication. Interface authentication, you need to do it on the interface. ISIS authentication mode. So this is under the interface. So this is under the level 2, level 1, and this on the interface. So far, okay? Any question on this ISIS IPv6, v4, and also a multi-topology? So I'm going to save the information for this lab and share you the full lab, so at least that you can be refer back what we did for this ISIS lab. Okay. So from here, I just to save. Okay, I share the two file already, the config file and also the text file. Okay, so the next one we go into is on the BGP and BGP 4 plus. So BGP is just standard as a IPv4 BGP. BGP 4 plus, it means that they're going to define as a IPv6. Okay, IPv6. And also at the meantime, just let me capture the attendance for this morning. All right. So the next topic is on the BGP and BGP 4 plus. So as we know that BGP as a EGP protocols, okay, it's an exterior gateway protocols. For this BGP protocols, we're going to use is only between the autonomous system. Okay, so that can be transmit your V4 and V6 route between the autonomous system. So we go through a bit on the unicast, on the IPv4 unicast into your HCIP. So they're going to also know about all the attribute that we're using on the BGP. So from over here, we just give you some refreshment on what are the attribute we're using, what are the BGP principle we're going to be going through. And next, we go into the BGP 4 plus. So BGP 4 plus is just like the extended BGP. So BGP very similar to ISIS. They do not need to. They can be easily adapt. It be very easily scaled to support on IPv6 or multicast VPN and so on. So they can use the easily just extend their BGP functions. We call this as MP BGP, multi protocols BGP protocols. Okay. So in this case, a BGP 4 plus is considered one of the MP BGP. Just that 4 plus is supporting on the IPv6. Okay, supporting on the IPv6 that we're going through. So under the forward here is on the BGP and BGP 4 plus is a dynamic routing protocols that's transmitting V4 V6 between the AS, and BGP is more to control the route advertisement and select the optimal route between the ASs. Compared to the IGP, what normally IGP done? IGP will be just more focused to discover a new route and select the best route back to the destination. But for BGP, it's more to how you control the route, which route you should use. Either you accept this or not accept this. It's all depend on the how you controlling the route information. Okay, and select the optimal route between the AS. Okay, when you have control already, this is what you can get. Then next, I will going to based on what we should specifying, which is the best part, which is the optimal route for me to accessing to the destination. Okay, so that is on the BGP and BGP 4 plus. And to implement the MPLS VPN, we need to have a MP BGP. It needs to be configured inside the AS and between the ASs. So that is what is required when we talk about on the MP BGP. When we want to go for the VPN services, we need to use a multi-protocol BGP protocols. And for this objective here, we need to get the fundamentals of the BGP forecast, basic configuration on the BGP, and the troubleshooting on the BGP roadmap. So for BGP, we're going to have two topics. One is on the basic, and the other one is on the advanced. Okay. For basic, it be today. Today we cover all the basic, and tomorrow we go for the advanced BGP protocols. Okay. Under the BGP fundamentals, first we need to just base the basic overview of the BGP, the concept of BGP implementation, what are attributes that we have, and how to perform the route calculation for the BGP fundamentals. Then next, we only go up to the BGP 4+. Okay. First, the fundamentals. We need to know the overview, the concept of handling the route, the concept of how they deal with all the traffic that coming in or going out, how you implement the BGP, what type of method you can implement, and the attribute that we have, how many attributes in total inside the BGP we can use, and how the BGP perform the route calculation. Okay, that is what we need to go into for this BGP fundamentals. It's more to the overview or review that what you learn on the HCIP. So under the BGP overview here, BGP is run as a EGP protocol. It's an exterior gateway protocols. Okay, we have EGP and we have a IGP. Okay, IGP within AS. Okay, EGP between AS. Okay, one is within, one is between. And the TCP as a transport layer protocols. So you still remember what type of port number they're using inside the BGP? Why they need to use a TCP? To make it reliable. Okay, because TCP go for a three-way handshake. So they're using a TCP port 179. And using a port 179 for them to form the connection. After connection form, then only they can establish the BGP connection. They need to do it step by step. TCP first before you can form the establishment. And next, as a CIDR, a classless inter-domain routing. Okay, classless inter-domain routing. This is what it means that they can support any subnet mask. It can be the /22, /29, any subnet mask is a classless. So they do not follow the classful address. So you can be easily aggregate into the classless information. Okay, any prefix that you want to be summarized into. And the more important over here is they can support on the incremental route update. But before that, do you know that BGP is belong to link state or distant vectors? Which one they belong to? So for BGP, it's belong to a distant vectors, the advanced distant vectors, or we call it as a path vectors. Okay, that is where they are based on for the BGP. So when BGP based on distant vectors means that they are based on the hop count, just like RIP. RIP to discover where is the best path, they based on the hop count. But just that in BGP, they have a lot of different criteria. Except the hop count, they can be specifying how to define the optimal route. So that is the benefit by using BGP to define how the route being controlled by BGP. The control route done by BGP will be much more method to define on the route control. Okay, compare to the RIP. RIP is just based on hop count. That's all. I don't care the rest. So BGP, not only based on hop count, I can base on the preference, I can base on the weight, I can base on also the IGP cost. Okay, a lot of information can be based on before I specify my optimal way. Okay, and when using a distant vectors normally they're using a routing table update. But using routing table update, you means that you need to wait for the timers. 60 seconds for the timers will be pretty long for the BGP. Okay, that's why the good over here that can be provided incremental route update. So when I have a changes of my route, I can just provide the incremental update to you. I will not share the entire tables to you. I just share whichever that have changes and I give it to you. Okay, that will be the better compared to the RIP. RIP is just share the routing table updates. They are not doing the incremental updates. Okay, because do you know that in entire world, around the world, how many BGP route that we have? How many BGP route in total that we have? Do you know the amount of this? Right now, it's about 500,000 of route that we have into the global. You imagine, let's say every time I send you a routing tables, I send about 500,000 of route to you. How long is it going to be processed? Before you finish process, maybe I send you the next one already. Okay, so that is a problem. Why? That is also the factor why they're going to shift to the incremental route update. So I only give you the route update for the changes, the incremental changes. I will not share the entire table to you because in this case, that will be very terrible. Because about 500,000 of route, you might need to take half a day, 12 hours, just to perform all the calculation one at a time. Okay, so it's not can be do it immediate, but before you calculate fully, maybe the next will be coming in already. That's why in BGP they are not advertise the full routing tables. They will advertise only the incremental route update. But definitely for the first time they learn, they need to learn the entire tables. Okay, only on the first time. Subsequent, they will just learn on the incremental route information only. Okay, it's considered a path vectors routing protocols. The path over here is a path is considered an AS. One AS is one path. Compared to RIP, one routers is one hop, but this is one path. The entire AS as one hop for me. So that's why it calls a path vectors in the BGP. Loop free. So how BGP provide a loop free? So do you still remember that what you learned from your HCIP? How they provide a loop-free environment? How they provide a loop-free environment into BGP? So in the loop prevention, they need to consider two things. One, a loop prevention within AS. Another loop prevention between AS. So need to know the two methods, how these two areas to have a loop-free environment. Okay, within the AS, what type of prevention we can perform? Do you still remember how they are prevent loop within AS? I'm not sure. Do you remember the principle of the advertisement that done on the within AS? Just remember the principle of how we advertising the route. The principle number 3. Can you still recall from your HCIP? Okay, never mind. So based on that principle, is that when IBGP receive an update from, or I doing, and I just rephrase again. Okay, that is the principle that when update received from iBGP peers, that you only can send to eBGP. So whichever update you learn from iBGP peers, you cannot send to iBGP anymore. You have to only send to the eBGP. And this is how they're doing the loop prevention within the AS. To say that when I'm the iBGP, you are the iBGP. Okay? When I send the update to you, you only can keep for yourself and send to eBGP, and you cannot send to the next iBGP. So something like this, let's say I have an environment like this, router A, router B, router C. So they belong to an AS. Okay, I have an eBGP connected to me. Traffic coming in. So when traffic coming in, when whichever I learn from eBGP, I can send to my iBGP. And this principle right now is referred to this. When I receive an update from the iBGP, I cannot send to the next iBGP. I only can send to the eBGP. Let's say if any. Yeah. You can only send to the eBGP, but not to the iBGP. That is to preventing the loop. Let's say you keep on sending to iBGP and forward, you might get a duplication, or you might get a routing loop inside your AS. So there is a principle to say that don't send to your iBGP when you receive an update from your iBGP. Okay, that is the rules, the principle into the advertisement rules to tell that that is the one to doing the loop prevention. Yeah, this is how they're doing the loop prevention within an AS. Okay. Then you will ask me, in this case, how router C receive, since you cannot advertising. So that's why a full match in your AS is required. Okay, a full match inside your AS is required, so I can send as a full match connection. Okay, so far, all right. So this is within AS. Then how about the between the ASs? Between ASs, they're using the AS path list to doing the between AS loop prevention. Is all right for this BGP loop prevention or loop-free environment. How they build the loop-free environment is all based on what you have inside your principle in the within AS, and also using the attribute between the AS to preventing the loop. So far, any question for the loop-free? Can you recall some information from your HCIP? All right, so let me stand up a while. Sit too long already. Okay or not? Up to this point. Loop-free, next, they have a various routing policy can be deployed. So you can doing all the route policy to control, like you set the attribute, you set the communities, you set some of the attribute into it to filter the route or to control the route that receiving or forwarding. So this way we can add on the routing policy. And also they can prevent a route flapping in BGP. So they will have a single features to prevent a route flapping. It's called a route dampening. Okay, route dampening. Later for this, we're going to mention on that. Speed horizon. Which one is a speed horizon? It means the loop free, or sorry, I just saw your message. Which one you're referring to for the BGP speed horizon? So the loop free in iBGP is not the speed horizon. Speed horizon default is already there. Speed horizon, it means that when I receive this information, I will not send back to you. Whichever I receive, I will not send back to that direction. This is not speed horizon. The speed horizon is that when I receive from you, I will not send back to you. That is called a speed horizon. But this advertisement principle, when I receive from the IBGP, I will not send to the next IBGP. So this is not considered a speed horizon. Speed horizon, for all the protocol by default, they're already there. Every single protocol that we're using, whichever I receive, always you will not send back from that direction. That is already there. It's just that RIP required to configure manually, but for OSPF, ISIS, BGP, the speed horizon, they are not applied from here. Okay? Okay, understood? This is not called as a speed horizon. This is just to a principle of the advertisement rules. Whichever I receive from the IBGP, I will not send to the next IBGP. Not the way I receive from. I send to the next IBGP. Alright, thank you. And BGP is easy to extend. So how they extend into the BGP? What type of extend method they're going to use in BGP? So they can use just a MP BGP to perform the extension using the MP BGP. That is method of the extension. They can easily extend directly. So far, okay? Do you have any questions so far? Before I go into the message type. Alright, so the next one is on the implementation on the messages. What are the message that we send inside the BGP? Okay, so over here it shows that we have in total 5 messages. We have a open, update, keep alive, notifications, and also a route refresh. So this is all the messages we send using the BGP implementation. When we implement the BGP, they need to go through the state machine, how they're going to send information. So remember that in BGP, they first need to form a TCP connection. When TCP connection is formed, then only they send the open, then keep alive. So normally this is the 2 messages they will send when on the initial part. When initial the BGP peers, TCP form already, the next step I send open message. Then keep alive. Keep alive, you will send periodically every 60 seconds. I will keep alive with you every 60 seconds. Open message, you just send once. When you receive, confirm, I will not send open message anymore. So these are the 2 messages for us to perform the establishment of the BGP peers, okay, using the open message. And keep alive is just keep alive periodically. Update message is to exchange your route between the BGP. Only when you're advertising route, then they will send update message. Otherwise, they will not send the update until you advertising your network into the BGP. You still remember how many methods of the advertisement network into BGP that we have? We can using the network or import route. These are the 2 methods for us to perform the advertisement of our network into the BGP. So either one of them you define, then they will send the update message to the peers. Okay, this is only when you're advertising, they will send the update message. They will exchange the information between the peers. Okay, that is on the update. notification is used to notifying the error. So it means that when you have error between the peers, I will send you the notification. Or you can say that when your peer are down, then they will send you a notification to tell you that why my BGP peer down. I notify you what are the reason your BGP are peer down by using the notification messages. Okay. Route refresh message. Okay. Request the peers to retransmit route if routing policy are changed. This one only when you have a changes of routing policy, then only I will send the route refresh. Okay. Otherwise, I will not send. Only when you have any policy apply into your peers. Let's say you define a route policy to the peers, then I will send the route refresh to ask, hey, any changes happen in my route policy or not? Let's say yes, I need to reconsider the selection of the best route. Is that okay? That is on the route refresh messages. So these are the 5 messages that we are using for the BGP implementation. Okay, inside the messages, 5 messages. But the most important messages for them to form establishment, 2. Open and keep alive. You do not have update, it doesn't matter. You do not have notification, it's good, it's best. Because when you have notification means that you have problem with your peer already. So by right, we do not want to see notification. Okay. So you want to see the open and the keep alive. Okay, this is on the message type that we have in the BGP. So far, okay, any questions? All right, next. For the state machine. Under state machine, we have an ideal, connect, open send, open conform, establishment. Under connect, they have an active. So for start from ideals, they go for connect. Connect is to establishing the TCP connection. Let's say successful, open send. When not successful, they go to active. Active, they're going to have a timers. Timer expired, go back to connect. Try one more time. Fail, active again. So they're going to retry between connect, active. Okay. So when your state is under active state, it's not means that you already active. No. When you're active state, it means that my TCP is not formed at all. When TCP is not formed at all, open message will not be sent. So you can see that when I send my open message, after TCP established, then only I will send the open send. Open message send from a direction to the peers, receive, correct, then they open conform. After open conform, they will just keep sending the keep alive to make sure that both are alive, both are active. Okay, both are active. It is up to the establishment. So anything happen, they will send the error back and go back to the ideal state. So that is how the process is being done when you go back to the ideals. Ideal means that after you feel after the 5 times of retry on the TCP connection, I cannot form, I will just fall back to the ideal state. You are not able to form. Is that okay or not? That's on the state machines inside the BGP. They must go in through this way. So you can see that only send the open and keep alive. These are the 2 messages that we're sending inside the entire state machine up to establishment. Okay. So it means that this is just like forming the neighbors relationship. Okay. Form the peer relationship. Update, it can be do it later part. Okay. Update can be do it later part when you have the network statement or import route been done, then only I'm going to advertising the route to the peers. Okay, using the update message. So update message, they have 2 roles. Update the route and withdraw the route. Let's say you said that right now this route is not valid anymore. I will need to withdraw this route from my peers. hey, this route need to withdraw. I tell my peers, remove this route. I need to send a update message as well to ask the peers to withdraw the route. So that is the state machine that we have on the BGP implementation. So far, okay? Okay. So from these TCP connections, how you know that they can form using a TCP connection? Over here, you need to be very clear that how you define the addresses you are using. So what address you are using here? Let me just extend another pages for me to draw something from here. Okay. For a TCP connection that we have, router A, router B. So how this can be defined between the peers. So I have a 12.1.1.0, 24.1.2. This is a loopback. This is a loopback. So under TCP connection, they have two ways of forming the TCP connection. You can using a direct connected or using a loopback connection to form the TCP connection. Okay. So for the first method, let's say from the router A are doing this. So I think that this command you should be very familiar already. Okay. I have a BGP 100 peers 12.1.1.2 AS numbers 100. Router B BGP 100 peers 12.1.1.1 AS numbers 100. So normally this is how we did using a physical IP to perform. So when we're doing during the TCP connection, so it means that from router A, router B, they were generating the TCP connection. TCP sessions. TCP sessions. So TCP section over here, they define the source and destinations. Okay. Source and destinations. Source over here is 12.1.1.1. Destination is 12.1.1.2. This is my destination. Okay. Source is 12.1.1.2, 12.1.1.1. This is my destination. Okay. So far, right. That in this case, they can be easily informed between the two peers. BGP 100, BGP 100, because this information is matched. Okay. When incoming, outgoing, it match the information, that is clear that you can form the TCP connection. All right. Oops. Okay. So let's say right now, I want to use a loopback interface to pair with the peers to do the BGP peers. So I'm going to modify in this case. I change from here. Okay. So when using a loopback interface to peers, I have to pair to 2, 2, 2, 2. From here, as a pair to 1, 1, 1, 1. So we have all these peer only, because this information be assigned into a destination IP information inside the TCP sections. Okay. So in this case, my destination right now is follow based on my configuration as a 2, 2, 2, 2. 1, 1, 1, 1. The source address is always which interface that you're going out to the destination. So it means that your physical and IP addresses as 12.1.1 and 12.1.2 is still remain as your source. But in this case, right now, the source and destination is not matched. So TCP cannot form. Because whichever I open and whatever you open will not match. Okay, I open this section for you. I will assume that whichever you point in my source is your destination, whichever is your source is my destination, like this. So I open this section, but when it come to me, no, this is not the correct information that I'm expecting. I'm not expecting in this information. This what I'm expecting is this information. Okay, but when you're doing this, you expecting is from loopback to loopback. So in this case, we need to add on another command for them to allow to form using the loopback. Is using this peers 2222 connect interface loopback 0. Okay, this one is tell what? This will tell you that what is your update source. Your update source right now are not using the physical. Use your loopback as a source. Okay, connect interface means that right now I change this information to my source. Okay, to my source using a loopback, not using physical. Okay, you force them to change. So in this case, after I perform this connection interface loopback 0, I will use as a 1.1 as a source, 2.2 as a source. Okay, and now this is match and TCP can form. So it means that let's say you found that your state of the BGP is under active. You have to check whether do they using a loopback or physical, or the address are configured wrongly and so on. So this is what you're going to check. When the status is active, you have to check this configuration. Okay, this configuration, whether it's already been done of the forming this correct information you're going to allocate it between the peer or not. It's okay. Good. No question, huh? So this is on the TCP connection. We need to really understand first before the BGP message can be sent. Even let's say this you cannot understand and this cannot be formed, you cannot exchange any BGP route at all. Okay, no BGP can be forwarded without this information. Okay, so next is on the BGP implementation, the database. Okay, the database. So in the database, we have IP routing tables, BGP routing tables, BGP peers database, adjacent rip in, adjacent rip out. So why we have so many database over here? So this is our normal IP routing tables, and that is our BGP routing tables. This is a neighbors tables, the peer tables, and this adjacent rip in, rip out. So this is facing to the where you receive the route and where you send the route. This is on the rip in. You store the route that you receive. Okay, this is sending. The route you before you send, you keep inside the adjacent rip out. Before you receive, after you receive, you will not go direct to your BGP tables. You go to the RIP in first. Okay, that is the database that we have. Routing tables, BGP routing tables, neighbor tables, RIP in and RIP out. Okay, RIP in, RIP out is just to say that that is the where you receive the route and where you send the route. That is the database they're going to keep before they're sending out the information. That's where it look like. So under when they receive update message from the peers, they first go to the adjacent RIP in. They will not go direct to your BGP tables. They go for adjacent RIP in, and they pass through the input policy engine. So this is where is your filter policy. You can filter before they go into my BGP tables. Okay, then in this case, it will affected me. Let's say everything is be done, select the path in my BGP tables. And I will select the best path to the IP routing tables, as well as optimal path it will be sent to the outbound policy engine. Another filter here. Another filter policy can be done before you send out to the peers. Okay? So that's why there are going to be a lot of layers of filtering. You can say that I want to filter when they come in, or I want to filter before they go out. So wherever filtered before they come in means that you affected you. So you apply to yourself. Whichever you're going to send out only filtered is not affect yourself, you affect your peers. Okay? Means that this information that I want to keep as original, but when I want to send to you, I modify it before I send to you. That is under the out policy. In policy is affecting you. Whenever you change, you're affecting to you. Before you receive, you modify the information already. Okay, that is the way of how the BGP route information it get processed. So they need to go through all this process. So far, okay? They're going through multiple database to learn doing the information. But by right, they will just direct go to the local RIP and go out to the RIP out. Let's say you have no policy defined. By default, there's no policy defined. Is it okay? So the route information processing. And the next one is on the interaction between BGP and IGP. How do we interact between BGP protocol and IGP protocols? The interaction between this, that is on the principle that I earlier on mentioned, but the sequence over here is slightly different. Well, it said that advertise the route learned from IBGP peers only to eBGP peers. And this is a principle that I mentioned just now. That is how we're going to prevent looped within AS. Within the AS, how the loop prevented by learning this. Learn IBGP peers, I will only send to eBGP. I will not send to the next IBGP. Let's say the route is obtained from eBGP peers, you can send to eBGP and IBGP. You can send to everybody's. When I learn from eBGP, I can send to everybody's inside the AS. Either it's eBGP or IBGP, no problem. And in BGP, on the advertisement, they only send the optimal BGP route to his peers. So let's say I receive multiple routes, but I only will share one optimal route going to my peers. When they are going to the same destination, let's say multiple ways to the same destination, I only give you a optimal one. Something like this. Okay. I send to C, I send to D. C, send to A, D, send to A. A, you should receive both. You should receive on the 100, 111. But when I send to B, I only send the Optimus. Okay, only send the optimal back to router B. So based on how I define these optimals, they're going to have their own selection criteria, okay, selection sequence to define which will be the optimal route. But how to differentiate is the optimal route? They're based on this. They will found this inside the BGP tables. Something like this. Asterisk and greater signs. Okay. The asterisk over here, this asterisk is called valid. This route is valid. And this greater sign is called is a best. It means it's the optimal. Okay. The greater sign is tell that this route, this path as a optimal route. And the asterisk is just to tell that this is a valid route. That's all. And the send only the update BGP route, synchronized route between iBGP and IGP. Okay. So this straightforward, they only send the incremental route. Any changes of the route, I will send. There's not the changes, I will not send. That's what we mentioned earlier on. And the last one is on the synchronized route between iBGP and IGP. So this one, this function, this function is disabled by default, and you can't enable back on this function. Okay, disabled by default and cannot be enabled. Okay, now for the synchronous route of the iBGP and IBGP and IGP. So what it mean by synchronization? At least that you know the concept. Why nowadays this function disabled and cannot be enabled anymore. Okay, so you need to know the concept. So I think HCIP already mentioned a bit on this already, but from here I'll give you more ideas how this representing, what it means by synchronization. Okay, synchronization happen is always when you have a transit AS. When you have the transit AS, within the transit AS, it's not all the routers running IBGP. So between this router 3, they are running IGP. Okay. So what I'm going to do from here is I withdraw this and show you a proper one. Okay. Okay, so that is in my 3 different AS. I have a router A, B, C, D, E, and right now I'm using the red colors to show you that what is the peers that define between. So router A and B, they are forming the eBGP. D and E, they're forming the eBGP. And between B and D, they are forming the IBGP. Okay, so it means that my TCP tunnels, my TCP connection, will be built like this. Okay, this is my BGP, IBGP. This is my TCP connection. Okay, so far alright. They have eBGP, IBGP, and eBGP. And now the information advertising. This advertising 100.111 I sent to router B. Agree? So router B, you receive this as a best valid 100.1.1.1, and this one is going through where? Router A. So yeah, router A, like this. And next, this is my BGP tables. They also have IP tables. Inside my IP tables, I'm going to just show I have 100.1.1.1 learn from BGP. Next hop is router A. This is my IP routing tables. Router C, in my IP routing, have nothing, have nothing, because router C is not a BGP speakers. Okay, router D. So this information will be sent into the tunnels, sent into the TCP connection, back to router D. C is not aware because C is not running BGP. C is just sent across the destination to router D, and I will have the BGP .100.1.1.1. Next hop, router B. In my IP, I have 100.1.1.1 learn from BGP and come from router B. So in this case, this information will be sent to router E. This is without the synchronization. This without synchronization. D sent to E. E received as a BGP. Next hop is router D. Okay, that's where they are going to be forwarding all the information from hop to hop. This is a route advertisement. Yeah, route advertisement. And now the next one is to the path the data advertisement. The data come from E, router E want to go to destination of 100.1.1.1. So I want to send this information to router D. D, oh, I check my routing tables. I not check my BGP, I check my routing tables because routing table is doing the data forwarding. BGP table is just to advertise and learn route. So that's why based on the path, they always need to select the best back into my BGP. So when I go to router D, oh, I know how to go to 100.1.1.1. BGP is going to connect to the router B. So I'm going to send to the router C. This is the physical way. I cannot go into my TCP connection because it's not related to my TCP anymore. This is just a data forwarding. When I go to router C say, you want to go to BGP 100.1.1.1? No, it's not in my list. Dropped. You can't send because this is not what I have. I do not have in my routing tables. I just drop. So this is how the behavior happen inside the routers. Okay. In the layer 3, when I do not know, I will just discard. So even though router E can learn the route, but router E cannot go to the destination because of in the transit AS, I did not fully enable BGP. So that's why to avoid these things, what they're going to do on 10, 20 years ago, they do this. Before I send this information, before I send out, I need to check. Based on this route, do you happen inside the IP routing tables? I need to make sure that they have running this using OASE. I need to make sure that this route is here before I can send this information to the peers. It means that my BGP table that I want to send, make sure they happen inside my IGP as well. IGP means that OSPF or ISIS. Okay, I make sure that this route is there before I will send this. Let's say this route is not here. So sorry, I will not send to you because I did not know, because my transit area, they do not know how to forward. I cannot send to you this information. When your IGP and the BGP table are not synchronized, I will not give this route to you. So that's why when you're running on the synchronization, you have to do this. On router D, you have to go to the OSPF, import route BGP. Import all your BGP route into the OSPF. So when you're done on this, you should have this 100.1.1.1 as a OASE. Connect to the router C. Okay, you have to do it on this side. Okay. So in this case, I will learn from RTC. So this one, I will learn this 100.1.1.1 OASE router B. So I have a 100.1.1.1 OASE myself. Okay. Then in this case, I will allow to send the message back to the router E to make sure that this and this are synchronized before I advertise a route into the Ethernet. This is what we call as a synchronization. Okay? That is what we call a synchronization. So it means that before I send any route to the eBGP, I have to make sure that that information is synchronized with my IGP information. When IGP is not synced, I will not forward this route out to the eBGP. So that is what it means on the synchronization concept. But just now I mentioned that by default, synchronization are disabled and you cannot enable. It means that the one I draw just now, they will send out. They will not check whether this is synced with your IGP or not. So it means that when synchronization disabled, what happened here is, it means that you did not do the import. Oops. Let me remove some of the information. I draw again. So this is not happening. So in this case, without the synchronization enables, then this route will be sent. So when this route is being sent, how are we going to solve to allow router C can be forwarded as well? So in this case, what they're going to do here is, instead of I going to build just a IBGP between B and D, I'm going to build a full IBGP, a full mesh of IBGP. So it means that I also will get this route information 100.1.1.1. Next hop, router B. So in my IP, sorry, this is my IP. Okay, this is my AS200. So I'm going to have this information as well, my BGP. What happened? So is that okay? On the synchronization right now, do you understand the between a synchronization and also the non-synchronization, disable and enables? And without able to enables, what you're going to do, we need to have a full mesh within your transit AS. Okay, transit AS must be full mesh connected. So in this case, I can avoid whichever that I send is not reachable after that. Will not. After I send, everything can be written. Is that okay? So far, any question up to this point? Grab the ideas, grab the ideas what it means from here already. How this AS communicate to the another AS. Okay, so far, any questions? All right. So next, I come back to this. This is where the explanation from the slide. Okay, so they will exchange this eBGP. Then they were going to drop by the router 3 because they're not running any BGP tables. The routing backhaul. Okay. Before an IBGP route is added to a routing tables and advertised to an eBGP peers, the BGP router first check the IGP routing tables. The IBGP route can be added to routing table and advertised eBGP peer only when the IGP obtain this IBGP route. That's what I mentioned. When the synchronization is enabled on router 4, I will check whether this IGP can go to the destination of 10.0.0.0 or not. Let's say it's not, then I will not send out at all. I will not send out this information to the next eBGP. Alright, and this function default disables and cannot be enabled, cannot be changed back into the environment. So that's why in this case, you need to perform the full match IBGP. Is that right? Okay. And next we look into the attribute. So do you still remember all this attribute, the 4 category of the attribute? We have a well-known mandatory, we have well-known discretionary, we have optional transitive, and also optional non non-transitive. So what's the difference between all these four categories? So still remember that what we teach on your HCIP? I'm not sure HCIP, I think it's not taught by me, right? It's by another instructors. So on the HCIP, first we know about the four categories. Like we have a mandatory, discretionary, transitive, and non-transitive. First, we need to know what is meant by mandatory. It means that when the well-known mandatory, they must be always included in your update message. So whichever that you send, they must be included into your update message. Let's say this attribute is not in the update message. When the update message is sent, it's no meanings. It's no meanings. They will just discard. They must include the attribute into the update message. And this one we call as a well-known mandatory. It's mandatory need to be inside the update message. Okay. Attribute of this must be identified by all the BGP routers and must include in the update message. Without this attribute, error occur in the routing information. So what type of the attribute is considered well-known mandatory? We have a origin, AS path, next hop. So these are the three well-known mandatory that we need to make sure that is inside the update message when you send. They must be included. Without these three, your routing information you might occur or error. But I do not know. Because without next hop, this route is not valid. Without the AS path, I cannot sure that the loop is happening. Without the origin, I do not know where you come from. It's not safe. So that's why these three information must be included when you send the update message. And this we call as a well-known mandatory. And secondly, sorry, well-known discretionary is to say that this can be supported by all the BGP device, but it's discretionary. It can include or not include. When you want to check this, you include. Let's say you not include, doesn't matter. It will not affect my information. Okay. Without the attribute, error do not occur in routing information. So it means that it's not compulsory. When you send, I understand. When you not send, okay, it doesn't matter to me. Okay. So this attribute must be identified by all routers, but they do not have to be included in the update message. Okay, it's not necessary. Like the local preference. It's not compulsory, need to be included inside the update message. Say yes, it's okay. You don't have, doesn't matter. Alright, that is what we show over here. It called as a local preference. And the next one is the optional transitive. Attribute of this type can pass to BGP peers. A BGP router may not identify this attribute, but it still receives this attribute and advertise them to other peers. Which means that this attribute, you do not know, doesn't matter. You can still send this attribute to the next peers. Okay, you can mean that you can transit this information to the next peers. And this attribute is not only given to you. You can also, this attribute can be passed to multiple hop away. You just have to send this out to the next peers. So they can be keep on sending multiple hop away. That is called the optional transitive. That one attribute is under this optional transitive. We call it as a communities. Community is one of the optional transitive attribute. Okay? They can pass to the BGP peers, can pass to multiple peers. As long as you enable it, they can pass through multiple peers. And the last one is optional non-transitive. It's not everybody understand. And let's say understand, you check, and this information is not transitive. It cannot be sent to the next BGP peers. I give it to you, it's only for you. This information will be useless when you send to your peers. Okay? attribute of this type cannot be identified by BGP routers. These attributes are ignored and are not advertised to other peers. It's only when I advertise to you, just keep it to you. You just get it and compare. When you do not know, you just forget about it. Okay, so over here they will have a MED, multi-exit discriminators, and also we have a cluster list, originator ID. Okay, that is considered a optional non-transitive. For these two, it only happen when you define the route reflectors. Route reflectors is inside the advanced BGP. They will cover it later part, okay? But from now, we will go through what is the origin, what is the AS pub, what is the next hop, what is the local preference, what is the community, and what is the MED. Okay, this is what we are going through at this point. So the origin attribute is a well-known mandatory attribute that defines the origin of the route information. So it's to tell that where you come from. You come from IGP, come from EGP, or come from incomplete. They have three different origin value over here. IGP, EGP, and also incomplete. Okay. For IGP, it means that the route you use a network command. You advertise using a network command. They always origin by IGP as an I. So there should be a small letter I. When you learn from EGP, they will get an E. Okay, but this attribute is no longer C. You no longer use this EGP. EGP is a protocol happened before a BGP. Before a BGP protocol, we have another protocol called EGP. But nowadays, nobody is still using EGP anymore. They will just using as a BGP as a protocol. So you seldom, or you might not, you will see the E as your origin anymore. You can see this when you do it manual changes. You're going to modify the origin to E yourself. Then you can see the E. Otherwise, you never see this. Incomplete, whichever route that you import route command, if it done, it will get this question mark. Okay, you get a question mark. Okay, so in this case, the preference will be something like this: I, E, question mark. Question mark, the least prefer. E, second, and I is a preferred. Right? That is on the origin. So let's say you learn the route from different origin, same destination, different origin. I will compare based on the origin. Which one has the best? I is the best. E second, and question mark will be the last. Okay, this is how they prefer. How they select optimal route when they have received a destination, come from three different origin. They will always prefer I, E, and question mark. Okay, from the descending method. Okay, I is the top, E second, and question mark is the last. Okay, for the BGP attribute origin. Next is on the preferred value. Preferred value. Preferred value, let's say you know about a Cisco BGP. This is equal to the Cisco weight, the weight of the route. Okay, the preferred value is similar to the weight in BGP. Okay, preferred value is a Huawei specific. Okay, Huawei specific and valid only on the device where it's configured. It's only locally significant. It's only locally significant. It's not related to others. It's only give it to when you have defined. You only compare yourself, and this information you not influence others. So that's we call as a local significant. And the preferred value attribute is user defined. Therefore, BGP first compare the preferred value during the route selection. Always this is the first way of selecting on the route selection. Like in router 1, I have two way, go to 10.0.0.0, using this way or using this way. So by default, let's say your preferred value is not defined, I'm using this way. This is my best way. Let's say you do not define the preferred value. But let's say you want to prefer using this way to go to the destination, using this way, you can set the preferred value to this 150. Default 0. Whichever higher is better. So in this case, I would prefer the 150 to reach my destination. Okay? That's how you can define. But only on your local point, only for yourself only. Okay, only for yourself. Is that okay so far on the preferred value? That is only proprietary by Huawei. Okay, we call it as a preferred value. But in Cisco, we call it as a weight. The weight of the route. And the next one is on the AS path. So just now you remember that I mentioned to you, under the loop 3, they're using AS path to prevent the loop. How they are preventing the loop? Let me ask you a question from here. Okay, let me just add a slide from here. Hold on, Let's say I have this scenario. So if AS1030 into my environment here, okay, let's say right now, let's say is this from router B. So do you think that this information, when passing through a round, they will advertising like this? Do you think that router A will accept this information or not? For the 10.0.0.0.24, do you think the router A will accept this information? Router A and B, they have no peering. They have no peering. They just stand alone BGP speakers. They do not running any peers between the A and B. They just belong to the same AS10. When this route advertising back to router A, do you think router A will accept this or they will not accept this? So what do you think? What do you think that will router A accept this information or not? Okay, I will just let you to think of this question. Let me just capture the attendance for this afternoon. Okay, for now, let's just capture another one more in case. So let me know the answer after I capture the attendance. So any answer? Yes or no? Can router A accept or not? Yes or no? Okay, so the answer from here is, okay, someone answer, accept then discard route. Accept then discard. Okay, so accept then discard, when they discard. Okay, by right over here, they will receive, this is what it means that they receive and discard. Okay, they will not accept and discard. They only receive and discard the information. Okay, so why they're going to discard? Because when I send this information out, let me just redraw this information. I doing show it as a hop by hop. Okay, I'll show you hop by hop from here. Okay, so when router B send to router C, okay, so what I'm going to send in my update message? Okay, inside my update message, remember, there must be include what information? Three information is mandatory. What are the three information mandatory? Origin, next hop, AS path. So it means that when I send inside my update message, if we include 10.0.0.0.24. Okay, this is IPv4. Origin and your path is together. Next hop is router B. Okay. AS path and also origin will be 10i. Let's say this is what I'm receiving. So I think that it's better for me to just write into the one line. It'll be easier for you to understand. Okay, I just write down this. 10.0.0.24, router B as a next hop, and followed by the AS path, followed by the origin. Okay, 10i. I receive. So router C, you will receive this as a best valid 10.0.0.0, router B and 10i. Okay, then in this case, this router C will send this eBGP. I will send this as I send 10.0.0.0, next hop router C, and is 30 10i. I include my AS inside the AS path, 30 10i. When router D receive, this is my tables, 10.0.0.0, then router C, 30 and 10i. Then this will be share this information out. I will have this 10.0.0.0, RTD, 20, 30, 10i. So when router A receive this information, I will check. Based on this information, I will check your AS path. Compare my AS path. It's matched. Okay, I discard. So as long as I see my AS information inside the update, I will not keep this information. I will just discard, because let's say I keep, the loop might happen, because I will never receive or I will never keep this information when the AS information, my AS is inside your AS path. Okay, that is the method how they prevent the looping between the ASs. Okay, they check based on the AS path. Is okay for this explanation under the AS path selection. This is how they're going to define which I select, which I not select. Okay, and next, that is an AS path. AS path is not only doing loop prevention, they also based on this AS path to specify where is my best path. So like in the AS100, which way is going to the R4 10.0.0 as a best? They compare, this is one path and this is two paths. Which one is better? One path. This is my best and valid. I will using this way to go to the AS300. That is what we call as a AS path. Okay, they can using the AS path to specify which is optimal way, And the AS path is also the one to provide a loop prevention between the AS. It's okay. But up to this point under the AS path, before I go further for the next attribute, up to this, all good. All right, let's say after this is all good, then I think that I will going to take a break right now. Take a lunch break. So we come back at 1:30 and we continue with the next attribute as a next hop. Okay, next hop. So let's take an hour break and we come back, continue with the BGP attribute. Okay, for the following after that, it'll be just a BGP protocol we're going to go through. All right, so I will see you in 1:30. Okay, see you in 1:30. Yeah.
Okay.
Okay. Okay.